Hello, hello. We've got a test coming up, and so I'm going to work through some of your review problems, and I'm going to try to make this as fast as possible because they're fairly long and complicated. So, to start us off, number one, it said you want to know when is the parametric equation x equals cosine of t and y equals sine of t increasing. Alright, so before you get mad at me, it depends what you mean by increasing. So if you graph this on your calculator, you might want to do that. It's fairly simple. It is a circle that starts here and works its way up, around, down, and then back to where it started, from 0 to 2 pi. Now, graphically, when is this function increasing? Would you say that it is increasing from here to here as I draw it? The y value is getting bigger, but if you take a look at that slope, the slope at any point, let me get a darker line here. If I take a point and I find the tangent line has a negative slope, which would point you towards decreasing. So if you found dy dx, which I did, it gives you cosine t over negative sine t. I'm sure you did that too. And if you made a sign chart for this, during that first interval, which I believe is from 0 to pi over 2, it would say the function is decreasing because it has a negative slope. The change in y over the change in x is negative, so it would give you a negative slope and would point you towards being decreasing. So there your sign chart would lead you astray. And so you can't do what you normally do. So a question asking when is this parametric equation increasing would probably not be something you would see. Instead, a question might be, when is the y value increasing? Okay. That would be a question that you'd probably see. Then, if that were the case, you would only find the derivative of y, which would be cosine of t. So y prime of t would be cosine of t, which if you did a sign chart for that, for cosine, you would start at 0 and go all the way to 2 pi, with pi in the middle, and pi over 2, and 3 pi over 2. And if you did a sign chart there, it's a little unnecessary for just one factor, but cosine is positive, then 0, then negative, then 0, and then positive throughout that whole time, right? Yes? And so that would tell you when the y value is going up, when your graph, as you draw it, is going up. So from 0 to pi over 2, you've got this much of your circle. Your y value is increasing. Then your y value is decreasing. So it's getting smaller. Again, your graph is going down, so your y value is decreasing, which our sign chart supports. And then your last period here from 3 pi over 2 to 2 pi, your graph is again going up, which our sign chart does support. And so it's kind of a bad question to ask, when is it increasing? Because the derivative of y with respect to x gives you the slope, not necessarily whether the graph is going up or going down as it draws the circle. Because as you can see, the circle is drawn possibly in some ways backwards. And so a traditional sign chart of the straight first derivative won't quite get you what you want. Thankfully, when we go to the next question, kind of part B, where I asked you concave up or concave down, we don't have this problem. You can just find second derivative and do a regular second derivative test. And so if you take the second derivative, d squared y over dx squared, that will of course equal the derivative with respect to t of our first derivative, which I have to scroll up to get again. There it is. Was negative cosine of t over sine t. All over dx dt, which was cosine t. I'm sorry, negative sine t. Yep, negative sine of t. And so let's see, a few things you can do here to make this easier on yourself. Cosine over sine is cotangent. And the two negatives will make a positive. And so you're left with the derivative with respect to t of just cotangent. And the derivative of cotangent, as you certainly know, is negative cosecant. So that will be negative cosecant t on top. The two negatives went away, so it's just a positive sine of t on the bottom. And when you do that, cosecant squared, my bad. The derivative of cotangent is negative cosecant squared. Writing too quickly. But of course, cosecant is 1 over sine. So that actually becomes negative 1 over a sine squared, and a sine makes a sine cubed. Alright. So there we've got our second derivative. And if we want to know when this is concave up and concave down, we make a sign chart for that. When is that going to be positive? When is that going to be negative? The cube doesn't change the sign of the function. It'll just keep itself. And so our two factors here. So we're going to have 0. We're going to have pi over 2. We're going to have pi. And then we're going to have 3 pi over 2. And last but not least, we're going to have pi. Sine starts at 0, then goes positive, and then stays positive, hits 0 again, goes negative, and then hits 0 again. Negative 1 is always, of course, negative. And so we go negative, negative, positive, positive. So that being said, our graph should start out concave down and then go concave up. So let's take a look. Did that actually happen? If we take a look at our circle, when it first was drawn, it went this way, which is concave down, and then it became concave up. So it looks like our sign chart for the second derivative to determine concavity it did actually work, and so we're good there. So I believe the question was, oh, you can find the intervals and write down those intervals. So that takes care of question 1. Let's add a new page here. Oops, that's not what I wanted. Alright. And the second question was, oh, we had a particle, that's right, or a projectile. X at t was equal to 5t cubed plus 8t squared, and yt was equal to 50. Alright, let's keep this going. 50 minus 2t squared. And the first thing was, how far did it travel in the first 4 seconds? So from 0 to 4. That one is hopefully pretty easy. That is an arc length. So you have to take the integral from 0 to 4. And then we're going to take the square root of 2 things squared plus something else squared. Oh, I put 0 to 0, didn't I? Oops. 0 to 4. Alright, so inside of our integral now, we have to take the derivative of both of these. So we have a 5t squared is going to become 15. I'll put it in a different color. 15t squared plus 16t. And in our other integral, we have negative 4t. Hopefully you remember that formula. You just take the derivative of x, and that goes into the one, and the derivative of y, that goes into the second one. Sorry for the odd arrows here. My computer is lagging on me. And all I have to do is plug that into the calculator. As long as you don't mess up any parentheses, you should get 449.224 as your arc length. I'm going to pause this video and start